What if you could outrun time itself? What if the second hand stopped ticking the moment you moved fast enough? What if every star, every galaxy, every moment collapsed into a single, blinding instant? To travel at the speed of light isn't just to go fast. It's to defy the very architecture of reality. It's to stretch time until it snaps, to flatten space into nothing, to exist everywhere and nowhere at once. This isn't science fiction. It's science pushed to its absolute edge. And tonight, we chase that edge, because to follow light is to see the universe naked. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. Imagine standing atop a mountain, surrounded by silence, so complete it hums. Above you, the night sky stretches like an ancient canvas, its stars flickering like ghost fires, some burned out long before your great-grandparents were born. And yet, their light still arrives, still speaks, still travels. Each photon that enters your eye is a time traveler. Some departed their home worlds just as Earth cooled from its molten youth. Others, like those from the nearest star, Proxima Centauri, began their journey 4 years ago. Still others left their galaxies when dinosaurs roamed, when pyramids were young, when no one on Earth even looked up. Light is the swiftest thing we know, 299,792,458 meters per second, fast enough to circle the Earth 7 times in a single second. And yet, even at that divine speed, it still takes over 8 minutes to reach us from the sun. That delay is not an error. It is a truth, a law, a mystery. But here's the question that burns through the boundaries of science and dream alike. What if you could ride that light? What if you could fuse yourself with it, become one with its velocity, and soar through the cosmos at the absolute edge of speed? It's a question that has haunted physicists, philosophers, and poets alike, because to chase the speed of light is to peel back the skin of the universe itself. Albert Einstein didn't just redefine physics, he shattered the very scaffolding of time and space. Before him, we imagined the universe as a stage, a neutral backdrop against which stars moved, clocks ticked, and people lived their lives. But Einstein said no. He said time can stretch like taffy, space can fold like cloth. He said reality bends when you move fast enough. And at the heart of it all, like a cosmic heartbeat, lies the speed of light. The faster you move, the stranger the world becomes. Distances collapse, clocks slow, events rearrange. What you thought was real becomes elastic. What you thought was now becomes relative. The speed of light is not just a velocity. It is the boundary between cause and effect. It is the ceiling of information. It is the limit to what can touch what. You cannot send a signal faster than light. You cannot outrun its messenger. It is not just fast, it is foundational. It's not just how fast things move, it's how fast reality updates. And yet, light is not made of matter. It has no mass. It doesn't age. It doesn't experience time. From a photon's point of view, its entire existence from birth in a star to its end in your retina happens in 0 time. What does that mean? It means light doesn't experience travel. It is already everywhere it's going. Time and space mean nothing to it. But to us, they mean everything. Our bodies tick in seconds. Our cities move in hours. Our civilizations rise and fall over centuries. Time defines what it means to be alive. Space defines what it means to be here rather than there. Without them, there is no journey, no destination, no self. So what happens when you dare to approach the speed where both begin to vanish? What happens when you try to ride the very current that defines the tempo of existence? That's what this journey is about. We are not here to build a spaceship. We are here to build a thought ship, one powered by paradox, by mathematics, by imagination, and by awe. Because to contemplate light speed is not just to fantasize about travel, it's to challenge the very framework of what we call real. It's to ask, what is time if it can slow and stretch? What is space if it can collapse and warp? What is now if it depends on how fast you're going? And perhaps the most unsettling of all, who are you if time stops flowing? As we step into this odyssey, let go of your ordinary senses. Let your grip on certainty loosen. The laws we will explore are not fictions, they are proven, tested, measured, but their implications? They are stranger than dreams. We will walk beside Einstein, yes, but also beside Schrödinger, Feynman, Minkowski, and the silent companions of the cosmos, the photons themselves. We will see how time bends like a reed in the wind, how distance becomes illusion, how simultaneity unravels, and how the universe guards its secrets not with locks, but with limits. Tonight, we don't just chase speed, we chase meaning, we chase the edge. And at that edge, between time and timelessness, matter and energy, presence and absence, lies the speed of light. It is not a finish line, it is a threshold, and we are about to cross it. It is the fastest thing we know, yet it arrives with ancient whispers, a messenger that doesn't age, doesn't rest, and doesn't forget. The speed of light is not just fast, it is absolute, final, cosmic law. And if there is a speed limit to the universe, then light is the boundary between motion and meaning. Light, we see it every day bouncing off windows, caught in sunbeams, flickering through the void. But what we rarely realize is that light isn't just something we see with. Light is something the universe speaks through. Every photon is a courier, a data packet, a story in motion. And the speed at which that story travels, 299,792,458 meters per second, is not just a number, it is the tempo of the cosmos. This number governs not only how fast light moves, but how everything moves, how matter behaves, how information spreads, how cause turns into effect. It defines the rules for everything from atoms to galaxies, from GPS satellites to black holes. It's woven into the very equations that describe reality, not just in Einstein's legendary formula E equals mc squared, where energy becomes mass and light speed is squared, but in Maxwell's equations, in quantum field theory, in the very constants that keep our universe from falling apart. So why is the speed of light the speed? Why that number? Why not faster? Why not slower? No one knows, and that's the mystery. It's not something we calculated. It's something we discovered hiding inside the structure of existence. Centuries ago, people assumed light was instantaneous, like flipping a switch in the void. But in 1676, a Danish astronomer named Ole Rømer stared into Jupiter's moons and saw something that changed everything. Their eclipses varied depending on Earth's position in its orbit. Why? Because light took time to travel. The moons weren't changing, our perspective was. Rømer cracked open the door, and what followed was a centuries-long quest. Scientists bounced light off spinning mirrors, synchronized beams across cities, fired lasers through vacuums. Eventually, we nailed it. 299,792,458 meters per second, the universal speed limit. And here's the twist that shattered everything we thought we knew. Light speed never changes. No matter how fast you're moving, how hard you try to catch it, no matter which direction you're going, you will always measure light as moving at the exact same speed. It's as if light refuses to acknowledge your motion. It doesn't care if you're standing still or racing through space on a rocket. It always outruns you at the same rate. This defies common sense. Imagine throwing a ball while standing still, it hits 50 miles per hour. Now imagine running forward and throwing it, it should go faster, right? Not light. It doesn't add or subtract. It stays perfectly indifferent. This puzzled physicists for decades. It broke their equations, broke their assumptions. It was as if the universe was whispering, you don't understand time, you don't understand space. And that's where Einstein entered the scene like a storm. In 1905, a young patent clerk dared to propose something radical. If light speed never changes, then it's not light that bends to us. It's us that must bend to light. Space and time must flex, stretching, squeezing, warping just to keep the speed of light constant. That single realization cracked open special relativity, the theory that fused space and time into a single fluid fabric called space-time. And in that fabric, the speed of light wasn't just fast, it was sacred. It became the maximum rate at which any change, any signal, any influence can ripple through the universe. Light became the referee of reality, the arbiter of what is possible. Nothing with mass can ever reach this speed, not because we haven't invented the right engine, but because the laws of physics won't allow it. The closer you get to light speed, the more energy you need to go just a little bit faster, and that energy requirement grows exponentially. To reach the speed of light, you would need infinite energy, and with that comes infinite mass, infinite momentum, and a universe that would shatter around you before you ever touched the threshold. Only photons, particles of light with no mass, are allowed to live at this speed. It is their birthright, their home. They do not accelerate to it. They are born there. Here's where things get stranger. From our point of view, light takes time to travel. It takes 8 minutes from the Sun to Earth. It takes 4 years from Proxima Centauri, billions from distant galaxies. But from the photon's point of view, time never passes. There is no journey, no middle. There is only emission and absorption, both happening in the same instant. Imagine that to move at light speed is to exist outside of time itself. It is not just speed, it is timelessness. And so, when we talk about light speed, we're not just talking about velocity. We're talking about the edge of becoming. We're talking about the limit at which our reality, space, time, information, identity begins to fail. Because to approach that speed is to stretch the canvas of existence until it screams, to slow time to a crawl, to crush distance into irrelevance. This is why physicists speak of light not just as illumination, but as a boundary condition. Light tells us what we can know, when we can know it, and what can cause what. If a star explodes 100 light years away, we won't know for 100 years. That delay is baked into the architecture of space. That delay protects the universe, prevents chaos, enforces order. It is as if the universe has a built-in buffer, a firewall between cause and effect. Light is that firewall. As we continue this journey, remember this. We are not chasing speed for the thrill of velocity. We are chasing light speed because it represents the edge of the possible, the final perimeter of experience and interaction. To touch it would be to dissolve into its logic. To become light is to surrender time. To move at that speed is to become part of the code the universe runs on. Next, we'll see what happens when you begin to approach that speed, how time bends, space shrinks, and your very self begins to slip. Before Einstein, space was a stage, time was a metronome. Together, they formed a fixed backdrop for everything that moved, burned, lived, or died. But Einstein walked into the void and whispered, "What if the stage can bend? What if the clock can stretch?" Everything changed in 1905. A young patent clerk with unkempt hair and eyes full of fire cracked the symmetry of the cosmos with nothing but thought. No telescope, no lab coat, just questions sharpened like blades. What Albert Einstein proposed wasn't just a theory, it was a reconstruction of reality. He declared, "Space and time are not separate things. They are one thing, space-time, and motion bends it." This idea did more than shake physics. It rattled the bones of existence. For thousands of years, we assumed space was like a container, infinite, passive, immovable. And time was the steady rhythm that ticked forward, impartial, universal, absolute. But Einstein shattered those assumptions. He revealed that if you move fast enough near the speed of light, space shrinks and time slows, not as an illusion, not as a trick of perspective, but as a physical consequence. Speed doesn't just move you through space, it changes what space island. Speed doesn't just make time feel slower, it makes time behave differently. This isn't metaphor, this is measurable truth. Atomic clocks flown on jets tick slower than those on Earth. Particles in accelerators live longer because their time is literally dilated. GPS satellites must account for relativity, or their signals would miss by miles. Einstein didn't just redefine the universe, He taught us that our senses lie. Here's the core idea. Everything moves through space-time, always, constantly. Even if you're sitting still, you're still moving through time at full speed. This total movement through both space and time always adds up to the speed of light. That's right. Even now, as you sit reading this, you are moving at light speed. Not through space, but through time. But what happens if you start moving through space? You must give up some of your motion through time. To go faster in space, you have to go slower in time. This trade-off is the core of relativity. It's not a suggestion, it's not negotiable. It's baked into the geometry of the universe. You can't cheat it. As you approach the speed of light, your motion through time slows to a crawl. At light speed, it stops entirely. From the perspective of light, time doesn't exist. There is no waiting, no past, no future. There is only now, always. This is why massless particles like photons must move at light speed, because they experience no time at all. A photon born in the belly of a star and absorbed by your eye a billion years later experiences that entire journey as a single moment. From the photon's perspective, there is no distance, no delay, just emission and arrival, instantaneous, timeless, absolute. And we move slower, not just through space, but through truth. Bound by time, we live inside a filtered version of reality, where change unfolds, where choices matter, where past and future feel separate. But the deeper you go, the faster you move, the more that illusion begins to crack. Here's where it gets even stranger. Einstein's insight forced physicists to rewrite the fundamental metric of the universe. Distance and time could no longer be measured separately. Instead, they became interwoven, measured by something called the space-time interval. This is the true distance between events, not just in meters, not just in seconds, but in a blend of both stitched together by light speed. And the space-time interval never changes. Whether you're standing still, flying in a rocket, or falling into a black hole, the laws stay the same. This is what makes relativity so radical and so powerful. The laws of physics are the same for everyone, no matter how fast they're going. But that sameness comes at a cost. We must give up our cherished assumptions. There is no universal now. There is no objective time. There is no absolute space. Instead, there is only relationship: how fast you're moving, where you are, and how gravity bends the grid beneath your feet. And speaking of gravity, Einstein wasn't done. 10 years later, he would go even further into general relativity, where gravity isn't a force at all, but a curve in space-time. Imagine a bowling ball dropped on a trampoline. That's a planet or a star, warping the very fabric of space and time around it. Now roll a marble nearby. It curves not because the ball pulls it, but because the trampoline is bent. The same thing happens to light. Even though photons have no mass, they still follow the curves of space-time. Light bends near stars. Clocks tick slower in gravity. Space stretches near black holes. Einstein's universe is not a static grid. It's alive, responsive. It bends when you move. It curves when you gather mass. It shifts and flexes like breath. So what does this mean for you, the traveler? If you could approach the speed of light, you would be diving into the architecture of reality itself. Your space would flatten, your time would slow. The rules you thought were fixed would melt like wax. This isn't a special effect. It's the normal behavior of reality, seen from an extreme perspective. And that's the point. Light speed is not just about going fast. It's about what the universe is when you push it to its limits. It's about discovering that motion and stillness, space and time, cause and effect are all part of the same strange dance. And light is the tempo. It is not the limit of motion. It is the limit of meaning. In the next chapter, we'll journey even closer to that threshold and see what happens when you start to stretch space-time around you, when time begins to drip and space begins to collapse. What happens to you when you try to touch light? What if your heartbeat slowed, but you felt no difference? What if you lived a year, but the world aged a century? What if the faster you moved, the less of you remained in time at all? This is not fiction. It is time dilation, the universe's most silent betrayal. Time, the great equalizer, the river we all swim in, or so we believed. But time, like space, is not what it seems. It isn't steady. It isn't absolute. It isn't fair. Time can stretch. Time can twist. Time can lie. And when you move fast enough, when you begin to approach the throne of light, time turns against you. This is time dilation, a phenomenon so eerie, so alien, that it sounds like sorcery. But it is real. It has been measured. It governs satellites in orbit and particles in accelerators. It changes how clocks tick, how hearts beat, how stories unfold. And the closer you get to light speed, the more violently time begins to resist you. Let's start small. You're sitting still reading this. To you, time flows naturally 1 second, then the next. Your thoughts tick like a metronome. Your coffee cools predictably. But now imagine stepping onto a ship not of steel and rivets, but of imagination and accelerating. 50% the speed of light, 500 590. As your velocity increases, a strange thing begins to happen. Your time slows down, not just metaphorically. Literally, clocks on your ship tick slower compared to those on Earth. Your body ages more slowly. Your thoughts unfold at a gentler pace. If you traveled for what felt like 1 year at 90% light speed, 2 years would pass on Earth. At 99%, 7 years. At 99.9%, 22 years. And at 99.9999% of light speed, 1 year for you would stretch to over 700 years back home. You would become a ghost from the past, floating forward while the world aged behind you. But here's the twist: you would never notice. To you, inside the ship, time feels normal. Your watch ticks, your thoughts continue, your heartbeat keeps rhythm. Everything is slow relative to the outside, but to you, it's business as usual. That is the paradox. You are suspended in motion, and in that motion, you are stealing time from the universe. Your perception is untouched, but your relationship with the cosmos changes forever. This is why Einstein's idea of relativity is so profound. It says, there is no universal clock. There is no master tempo. Every object, every observer experiences time relative to their motion. Time is not a single melody. It's a symphony of speeds, each playing its own rhythm. Think of this. There are particles called muons, created in Earth's upper atmosphere by cosmic rays. They live for mere microseconds, too brief to reach the ground. And yet, we detect them at sea level. Why? Because they're moving so fast. Time slows down for them. Their short lives stretch, allowing them to exist longer from our perspective. This isn't theory, it's observation. Or consider our GPS system, the satellite constellation guiding your phone as you navigate Earth. Each satellite orbits at thousands of miles per hour and must account for time dilation to remain accurate. If we ignored relativity, GPS would fail within minutes. Time dilation is not science fiction. It's a correction factor in your pocket. And the mathematics? It's governed by something called the Lorentz factor, a simple equation with terrifying consequences. As your speed approaches that of light, the factor increases, and so does the dilation. At light speed, the Lorentz factor becomes infinite, meaning time stops entirely. From the perspective of someone watching you, you become frozen, suspended, a moving statue. But from your own perspective, there is no passage of time, no waiting, no journey. You leave and arrive in the same instant. This is what a photon experiences. A star explodes, light travels, you see it. But for the photon, it was born and died in the same breathless moment. Now take a step further. Imagine you're the traveler. You board your ship, accelerate to near light speed. You wave goodbye, and in that wave, centuries pass. You journey for what feels like hours. You land, you open the door, and Earth is gone. Your home, extinct. Your cities, ruins. Your family, myths. You are still young, but the world you knew is dust in orbit. This is the exile of the lightspeed traveler, the one-way ticket into the future. A ship through space becomes a tunnel through time, and the price? everything behind you. This is not just a physical phenomenon, it is a philosophical reckoning. Because if time is not constant, then what is memory? What is presence? What is a moment if it depends on how fast you're moving? We define ourselves by chronology, by the order of things. I was born, I grew, I learned, I changed. But what happens when that order becomes relative? When now for me is not now for you? When simultaneity becomes illusion and sequence becomes flexible? At near light speed, two events that seem simultaneous to one person might occur in reverse order to another. Cause and effect blur. You can no longer say with certainty which came first, the knock or the echo. But what's most haunting of all is this. You could go anywhere, see anything, touch distant stars, but you could never go home because the earth you left would be unreachable, not in space, but in time. The speed you gained would become a prison, a liberation, and a loss, a miracle and a mourning. Time dilation doesn't just stretch time, it severs timelines. And yet, for all its strangeness, there's something beautiful here, because within the terror of dilation lies a hidden mercy. It means we are all moving through space-time together, each on our own unique trajectory. There is no universal clock, but there is a universal dance, and that dance bends reality, folds it, shapes it. We are not merely passengers in time, we are co-authors of its rhythm, and as we draw closer to light speed, we write that rhythm in strange new meters. Next, we leave the mind and enter the body, because while your watch may slow and your time may stretch, your biology must survive that bending. What happens to the human form when it flirts with light itself? The universe does not gently warn you when you go too far. It breaks you quietly, without remorse. And if you try to take your fragile, carbon-built body to light speed, it will not argue. It will simply erase you. Let's be honest. We weren't built for the stars. Our bodies miraculous, as they are evolved for soft winds, breathable air, and slow days. Every cell in your body assumes you'll never move faster than a sprint. Your bones expect gravity. Your organ expect pressure. Your brain expects time to pass. But at light speed, none of those expectations hold. Light speed is not just fast. It is a different regime of existence. A place where physics bends, time crumbles, and biology becomes incompatible. You can dream of riding a beam of light, but your body, it wouldn't survive the ignition. Let's start with acceleration. To reach light speed, you'd have to build up momentum, and to do that, you need acceleration. But there's a limit to how much acceleration a human can take. Fighter pilots, the elite among the elite, can handle around 9 grams is 9 times Earth's gravity for a few seconds. Beyond that, blood drains from the brain, vision tunnels, consciousness flickers. Eventually, the body gives up. Now consider what it would take to reach even 90% of light speed. The numbers are obscene. To get a 70-kilogram human, roughly 150 pounds, up to that velocity would require 8 times 10 to the power of 18 joules of energy, roughly the entire energy output of the United States for 6 months. And that's just for 90%. To go faster, the energy demand explodes exponentially. At 99%, you'd need 50 times that. At 99.9%, 150 times. To reach light speed would require infinite energy, and you can't contain infinity in a human ribcage. But let's say somehow you solved that. You controlled the energy, spread the acceleration across years, avoided G-force death. What then? The problem is mass. As you approach light speed, relativistic mass increases. You get heavier, not just by a few pounds, by orders of magnitude. At 90% light speed, your mass would be 2.3 times what it normally island. At 99.9%, you'd be over 22 times heavier. Your bones would splinter under your own weight. Your heart would fail trying to pump blood that weighs more than it was designed for. Your muscles would collapse, suffocated by the burden of mass they were never meant to lift. Imagine waking up one morning, and your body weighs 1,500 pounds from the inside. Even if time has slowed, Biology hasn't evolved to handle this new reality. But that's just the beginning. Light speed isn't just fast, it's energetic, dangerously so. Every particle in your body, every electron, every atom becomes a missile, accelerating to near infinite momentum. Your molecules become weapons not just against the outside world, but against you. Your electromagnetic field, usually so weak you barely notice it, would spike to lethal intensities. Your cells would generate synchrotron radiation, high-energy gamma rays that would cook you from within. You would be the reactor and the meltdown. And then there's the cosmic microwave background, a faint afterglow from the Big Bang, normally harmless, 3 degrees above absolute zero. But at light speed, it blue shifts, becomes gamma radiation. You are now plunging into a storm of ancient energy turned into a cosmic microwave oven that scorches you alive. And that's assuming you never touch anything, because even a single atom of hydrogen drifting in the void when hit at near light speed becomes a high-velocity bullet. Hit a single dust grain at that velocity, it would release energy comparable to an explosion. Your ship would shatter, your body would disintegrate, you wouldn't even know it happened. Light speed travel isn't like dodging obstacles. It's like running through a minefield where every speck of dust is a bomb. Still not convinced? Let's go deeper. Your molecular structure, the thing that holds you together, is governed by forces in delicate balance. At light speed, those forces break. Atomic bonds stretch. Quantum uncertainty balloons. Your particles, now smeared out like waves, lose their cohesion. You wouldn't just die, you would dissolve. Not metaphorically, literally. You would become a quantum smear, your atoms scattered across space like echoes. Your body would stop being a body. Your brain would stop being a brain. And consciousness, that flame you call you, snuffed out by momentum. But here's the final blow. Let's say somehow you reached light speed. Let's say the math allowed it, the energy aligned, the body endured. What would you experience? Nothing. No time would pass. From your perspective, your journey, no matter how long, would be instant. You would experience no breath, no thought, no awareness. You would leave and arrive. That's it. No in between, no memory, no self. You wouldn't be traveling, you'd be skipping existence. This is the horror and the wonder of light speed. It is not a racetrack, it is a horizon. Beyond it, biology cannot follow. Mind cannot follow, meaning cannot follow, because at light speed, the rules break. And when the rules break, so do we. So why explore it? Why chase this boundary, knowing what waits? Because within the failure lies truth. It teaches us that our limits are not just biological, they are cosmological. We are not built for infinity. We are built for experiencing it from afar, for dreaming it, imagining it, respecting it. Light speed is not for us to ride, it is for us to wonder at, and that wonder is what makes us human. Next, we leave the body behind, because while the flesh burns and bones collapse, space itself begins to shatter. What happens to distance, location, and direction when you reach the speed of reality itself? You're about to find out. The faster you go, the lonelier it becomes, not because you leave behind places, but because you leave behind eras. To move at light speed is to vanish from the present. It is not a journey through space, but a betrayal of time. The universe is vast. We say it casually the way we talk about oceans, or skies, or maps that fold too many times. But vast is the wrong word. The universe is unfathomable. Our galaxy alone, the Milky Way, spans 100,000 light years across. The nearest major galaxy, Andromeda, over 2.5 million light years away. And the observable universe? A gaping sphere of 93 billion light years, expanding every second. At everyday speeds, these distances are impossible. Even our fastest spacecraft, Voyager 1, would take over 70,000 years to reach Proxima Centauri, the star next door. So we dream. We imagine riding beams of light, crossing galaxies in moments, breaking the lock on distance itself. But when you move at light speed, you don't just escape space, you escape time, and that escape comes with a cost. Imagine launching from Earth at light speed. You're heading to Proxima Centauri, just 4.25 light-years away. From Earth's perspective, you'll arrive in 4 years and 3 months. But from your perspective, no time passes. You leave and you arrive instantly. Your clock doesn't tick, your body doesn't age, your mind doesn't think. You've slipped across space-time like a pebble skimming the surface of a pond, touching nothing, feeling nothing, yet somehow crossing everything. But when you look back, Earth is gone, not geographically, chronologically. Let's go further, to the center of the Milky Way, 26,000 light-years away, to Andromeda, 2,5 millions, to the edge of the observable universe, over 46 billion light-years distant. From your point of view, each of these journeys takes 0 time, because as your speed climbs toward light, the universe collapses in front of you. Distances shorten, time contracts. Everything along your path flattens into a single moment, as if the cosmos itself were folding, origami style, around your trajectory. But the Earth you left, it ages. If you travel to a galaxy 1 billion light-years away at light speed, by the time you arrive, 1 billion years have passed on Earth. The planet you once knew, the people, the cities, the history are dust. Your language is extinct. Your memory is irrelevant. Your very existence is a myth buried in cosmic time. You didn't just leave home, you left the epoch that contained it. And when you arrive, you don't belong there either, because while you've crossed unimaginable distances, you've skipped time itself. You appear ageless, untouched in a future that never prepared for you. You are a relic, a phantom, a spark from a civilization long dead. This is the paradox of light-speed travel. You gain access to the entire cosmos, but lose access to the only thing that made it familiar. You become a traveler without a present, an exile from your own story. This is not theoretical. It is encoded in the mathematics of relativity. The faster you move, the more violently your time separates from the time of others. This is called proper time, the time measured by your own clock versus coordinate time, measured by an outside observer. And the gap between those two timelines is not just academic, it is existential. It determines what you remember, what you forget, what you can return to, and what you never can. Let's bring this into emotional focus. Imagine a mission. You launch in 2100. You travel at 99.99999% the speed of light to a galaxy 10 million light-years away. To you, the journey feels like a weekend. But when you arrive, Earth is gone, the sun burned out. Humanity, if it still exists, has evolved, migrated, forgotten you. And if you try to return, another 10 million years pass. You arrive to a planet that may no longer orbit the same star, or orbit at all. You have, in every sense that matters, become a refugee from time. This is what light speed does. It trades connection for access, freedom for context, distance for isolation. You gain the galaxy, but lose your place in history. And that's the paradox that sits at the heart of light speed. It is the ultimate liberation and the ultimate erasure. You become unstuck from chronology, unanchored from memory, unmoored from meaning. You don't just lose home, you lose when home island. But there's more, because space itself, the very thing you thought you were crossing, begins to behave differently at these speeds. From your perspective, the universe flattens, distances shrink, galaxies blur together. The vast tapestry of cosmic structure folds into a thin sheet of stars. At light speed, space becomes meaningless. There is no left or right, no near or far, only forward, and even that loses its shape. You don't move through space, you collapse it. And this brings us to a strange, haunting truth. Light speed is not movement, it is redefinition. It takes all the things we rely on, time, space, memory, identity, and rearranges them. It turns journey into arrival. It turns person into phenomenon. It turns life into a ripple in the geometry of existence. And so we must ask, if you travel at light speed, are you still you? If no time passes for you, can anything still happen? If you leave a place that no longer exists when you arrive, have you truly gone anywhere at all? These are not metaphors. These are the consequences of touching the limit, of stepping across the edge of physics, of saying to the universe, I will not wait, I will not crawl, I will run at the speed of everything. And the universe replies, then you must leave behind everything you love. Next, we'll explore what happens not just to time, but to location. Because if distance collapses and time stops, where are you really? What happens to space itself? You're about to witness the paradox of universal presence. If time stops at light speed, space does too. But what happens when both the clock and the map go silent? When distance dies, where are you? When we talk about motion, we imagine it through space. We leave point A, we arrive at point B. The journey happens between in the space that stretches like a road under our wheels. But this story, the story of movement, begins to break down at the cosmic extreme, because at light speed, the road disappears, and the question of where are you becomes impossible to answer. Let's rewind. In our ordinary lives, space is reliable. We can point to things, navigate, build, return. Space gives meaning to direction, to location, to geometry, to existence itself. But Einstein showed us that space is not a static stage. It is a fluid, curved, and elastic part of space-time, twisted by motion, bent by gravity, fused with time. And as your speed increases, space begins to warp around you. Not like a funhouse mirror, more like a folding dimension reshaping itself depending on your motion. At low speeds, the effect is invisible, but as you approach light speed, everything collapses. Distances shrink in your direction of travel. Galaxies ahead appear compressed. Stars behind stretch like ghosts. The universe squeezes into a tunnel, all of it racing at you, collapsing toward you, like a cosmic funnel. This is Lorentz contraction, the shortening of space along your line of motion. At 99% the speed of light, space shortens slightly. At 99.999999%, it compresses violently. And at light speed itself, the distance to any destination becomes zero. Read that again. At the speed of light, all distance in your direction of travel becomes zero. That's not poetic exaggeration. That's physics. You're no longer traveling through space. You are everywhere along your path simultaneously. The entire span from departure to arrival exists in the same place, at the same time, from your perspective. The stars you pass them all at once. The space between galaxies, it never existed not to you. So now ask yourself, if all points collapse into one, if every location overlaps, where are you? You are not at point A. You are not at point B. You are in the transition itself, a pure state of relation between points, not a location within them. You have become a bridge between coordinates, a thread of presence that never stops to rest. Your existence has no address, only trajectory. This is the paradox of location at light speed. You are in motion, but you are nowhere, because place has ceased to function, because space has flattened into an instant. Let's use an analogy. Imagine watching a movie. Normally, each frame plays one after the other, a linear sequence through time. But now imagine viewing every frame at once. The beginning, middle, and end all layered on top of each other, flashing into your mind in a single, incomprehensible instant. That's light speed. Not a journey, not a progression, but a simultaneity. And you are not inside the story. You are touching all of it at once, but inhabiting none of it. This creates another mystery. If you experience no space between points, then every destination along your path becomes indistinguishable. In other words, from the photon's perspective, the entire universe exists in a single place. The Sun, Earth, Andromeda, the edge of the cosmos, they all occupy the same coordinate in light's reference frame, because light doesn't experience motion the way we do. To light, the concept of going anywhere is meaningless. Everything it reaches was already there. But here's the twist. Photons, particles of light, don't experience time. They don't age. They don't remember. They are outside the flow of causality. And in that same logic, they don't experience space either. So again, we ask, Where is a photon? Where is anything that moves at light speed? The answer is chilling. It's everywhere along its trajectory, but nowhere inside it. It is an event, not a traveler. A ripple in space-time, not an occupant of it. This is not a metaphor. It is built into the equations of special relativity. At light speed, time becomes zero, distance becomes zero, location becomes undefined. You do not move through the universe. You become non-local, an object without a frame of reference. It's as if the universe loses track of you. So what does this mean for us? If we ever built a spacecraft that could reach light speed or near it, we wouldn't be navigating space. We'd be falling out of it. We wouldn't pass through stars and dust and void. We'd collapse them into a blur of unreachable geometry. We'd vanish from the map, and the stars we hope to explore, they'd become places we could never truly arrive in, because to arrive requires being somewhere, and at light speed, somewhere doesn't exist. Here's the philosophical knife. To reach everywhere at once, you must sacrifice the ability to be anywhere at all. This is the ultimate paradox of cosmic travel. Not that we go too fast, but that we go so fast, we cease to go altogether. We lose location, we lose duration, we lose distinction, and in that instant of infinite compression, we become a ghost with no ground to haunt. So what's left? Only relation, only the ripple, the interaction, the shadow of influence. You are no longer a body in motion. You are a phenomenon, an interference, a flash in the structure of the cosmos. You cannot be seen or touched, but your presence warps everything. You are a trace, and traces do not live inside space. They live in the consequences they leave behind. Next, we confront the most profound implication, causality, because if time and space both vanish at light speed, what happens to cause and effect? If time no longer ticks and space no longer stretches, then what happens to cause and effect? What happens to meaning when before and after collapse into the same breathless instant? Causality is the spine of our existence. You breathe in, and then you exhale. You speak, and then the sound leaves your lips. You press a key, and then the note plays. This leads to that. It's how we know we're moving. It's how we know we're alive. A river of unfolding events, and we are its passengers. But the speed of light fractures the river. It snaps the flow in half. It turns the current into a mirror. And suddenly, the difference between past and future blurs until it's meaningless. Because light does not obey the arrow of time. In our universe, causality is sacred. If A causes B, then B cannot happen before A. The match must light before the fire burns. The stone must fall before it hits the ground. This structure, this logic is called a light cone. It's the invisible shape of what can happen, and where, and when. Your present moment sends out ripples into the future. Your past flows into you like a river. Everything else, everything outside that cone is unreachable, unknowable, causally disconnected. Until you move, fast, very fast. As you approach light speed, your light cone begins to tilt. The structure of what can influence you and what you can influence warps. Events that were once firmly in the future shift. Moments that should be unreachable start sneaking into your now. Cause and effect, they become subjective. In one frame, event A causes event B. In another frame, event B causes event A. In some extreme cases, they seem to happen simultaneously. And at light speed, the distinction vanishes altogether. There is no before, no after, only event, only coexistence. To light, every moment it touches exists in the same eternal now. The photon that leaves the sun and lands in your eye, from its perspective, both events happen at once. There is no journey, no gap, no causation. The emission and the absorption are one thing, two sides of a coin flipped outside of time. This isn't just theory, it's baked into relativity. Einstein showed us that simultaneity is not absolute. If two lightning bolts strike at the same time for you, someone moving past you might see one strike before the other. Ordre dépend en motion. Séquence dépend en perspective. Which means, causality is not universal. It's a construct, real, but conditional, and if we dare to ride the beam of light, we are entering a realm where even logic itself begins to fail. This brings us to a terrifying concept: retrocausality, the idea that the future can influence the past, that outcomes can reach backward and reshape their own causes. It sounds impossible, like science fiction, but in the quantum world, it's not only possible, it's observed. In experiments like the delayed choice quantum eraser, particles seem to decide their history after they've already passed through a system. You make a measurement now, and it retroactively determines what the particle did before. It's like opening a letter and watching your memory of writing it change in real time. What does this mean? It means that at the deepest level of the universe, beneath time, beneath cause, beneath our most sacred assumptions, reality might be a loop, not a line, a tapestry, not a track. Events might be entangled across time, just as particles are entangled across space. And the speed of light? It is the knife edge where linear logic collapses into quantum mystery. Now imagine this: you're inside a spaceship, approaching light speed. Your instruments distort, your perception warps. Suddenly, you observe a star exploding, a supernova. But the equations say something strange. The light from that supernova is just reaching you. Yet, from your perspective, traveling near C, that star died moments ago, or maybe hasn't died yet. Which is it? In your frame, it's both, or neither. Because sequence is broken, you cannot say what came first: the death of the star, or your arrival to witness it. You are no longer observing a timeline. You are swimming in a sea of entangled moments. This isn't just theoretical vertigo. It has consequences. In our dreams of interstellar travel, of communicating with distant civilizations, of building wormholes or warp drives, we must confront this terrifying truth. The faster we move, the less we can trust time. And if we cannot trust time, we cannot trust memory, we cannot trust choice, we cannot trust logic. Because logic is built on cause and effect. But cause and effect are built on time, and time under enough speed becomes a whisper, a suggestion. Ali, here's the most haunting question of all. If the future can influence the past, could the universe be choosing itself? Could every moment, past, present, and future, be part of a self-consistent pattern, a cosmic feedback loop, a block universe, where everything that ever happened or will happen is already there, frozen, complete, inevitable? In such a cosmos, free will becomes a flicker, and causality becomes a myth we tell to explain a story that was always written. You are not choosing what to do next. You are walking a path that already exists, lit by stars that have already died and still shine. At light speed, we glimpse this, not in clarity, but in distortion, not in answers, but in broken mirrors. You see cause and effect, and then you see through them both. And what stares back is a universe without a beginning, without an end, only a strange, timeless dance of consequence and echo. What if the barrier you seek to cross grows heavier the closer you get? What if the closer you fly to light, the more the universe itself resists, demanding a toll of infinite energy for just one final step? There's a number cold, precise, and merciless. 299, 792, 458 meters per second. That's it. That's the cosmic ceiling, the ultimate limit. Not because the universe doesn't want you to move faster, but because the very structure of space and time begins to fold in on itself as you try. It's not a wall you crash into. It's a wall that pushes back harder and harder the closer you get. An invisible gravity made not of mass but of mathematics. And its price? Energy. Let's return to the most elegant formula ever written. E 等于 mc 的平方. Energy equals mass times the speed of light squared. It tells us that matter is just frozen energy, that everything you are, every atom, every cell, is a bundle of potential waiting to be unleashed. But it also tells us something darker. To move mass close to the speed of light, you need more energy. And the faster you go, the more energy it takes. This isn't just a curve, it's a horizon Approach 90% the speed of light, you need twice the energy you thought. Push to 99%, you need 7 times more. 99.99999%, 22 times. And 99.999999%, you're now burning energy, like a black hole collapsing in on itself. To reach light speed exactly, to hit that impossible, perfect 100%, you'd need infinite energy. Not a lot, not just more, literally infinity. All the energy in the known universe, and it still wouldn't be enough. Why? Because your mass isn't constant. It grows, not in volume, not in shape, but in relativistic mass. The resistance to acceleration. The faster you go, the heavier you become. Not metaphorically, not poetically, physically. From your frame, you still feel light, still human, still you, but to the universe, you're turning into a gravitational demon, warping the space-time around you like a falling star. Your momentum becomes monstrous. Your inertia, unbreakable. You're dragging the entire weight of your speed behind you, and it's tearing the fabric of the cosmos with every tick forward. It's like trying to push a boulder up a hill that gets steeper with every step. At first, it's manageable, but the closer you get to the top, the boulder doubles in size, then triples, then becomes the mountain itself, and eventually, you're not pushing the rock anymore. You're pushing infinity. This is not a rule made by engineers. This is not a design flaw. This is the nature of reality. It's how the cosmos protects its secrets, how it guards the realm of light, a realm that no mass can enter, because to become light is to stop being matter. That's why photons, the purest messengers of the universe, can travel at light speed. They have no rest mass. They are born in motion. They do not accelerate. They simply are, and that's what makes them divine. They are the whispers of stars, the memory of galaxies, the only travelers who can cross eternity without aging a single second. We made of flesh and friction cannot follow, not in body, not without tearing ourselves apart at the seams. Now imagine this. You're piloting the most advanced spaceship ever conceived, a vessel powered by antimatter, dark energy, gravitational slingshots, every trick humanity can muster. You accelerate, faster, faster, 0 kilometers per second. Iwan, Wu-wan, half the speed of light. The stars begin to smear, time begins to dilate. You are aging slower than the rest of the universe. But each percentage point of acceleration becomes exponentially harder. Your engines scream. Your reactor bends the laws of physics. You are converting matter into motion with terrifying efficiency. But it's still not enough, because as you approach the final decimal places, as you crawl from 99.999% to 99.9999999%, the energy you need explodes into an infinite spike, and you realize you'll never make it. This is the unbreakable prison of mass. This is the line drawn in cosmic stone, not by malice, not by oversight, but by the very arithmetic of space. To cross it is to rewrite the equation of everything, and yet, that's what makes it so tempting. We dream of breaking the limit not just because we want to go fast, but because we want to become something more. We want to escape entropy. We want to flee mortality. We want to outrun the ticking clock that haunts our species from cradle to grave. And the speed of light? It's the forbidden fruit. It says, here is a realm where time does not pass. Here is a speed where no decay occurs. Here is a limit beyond which you might live forever. But there's a cost, because to live forever as light, you must surrender everything else. You must become a creature of zero mass, a traveler of no time, a ghost that never stops moving, but also never truly island. You can never land, never rest, never look back. You can only burn through space like a message, not a being. So we are caught in a paradox. We crave the freedom that light embodies, but we are bound by the weight that gives us form. We long to move faster, but speed itself becomes our enemy. We are children of inertia, chained not by chains, but by the curvature of equations written in the bones of the universe. And yet, there are whispers, speculations, Could we shed mass? Could we ride gravitational waves? Could quantum mechanics offer a loophole? Could consciousness, somehow, decouple from matter and ride the beam alone? The math says no, but imagination screams yes. In the next section, we dive into that scream. We leave relativity and enter the quantum jungle, where particles can be everywhere and nowhere, where time runs backward, sideways, and sometimes not at all, where the rules we just spent 9 sections learning break into dust. What if the closer we got to light, the more reality blurred? What if motion wasn't just speed, but a probability? What if you could be everywhere and nowhere at once? You thought you understood strange. You thought time slowing down was weird. You thought mass growing to infinity was wild. You thought collapsing space and warping perception were mind-breaking. But none of it prepares you for what comes next. Because now, we leave the clean curves of Einstein's spacetime and dive headfirst into the chaos of the quantum world, a place where logic dies, where particles flicker like whispers, where certainty is an illusion and observation is creation. Light lives here, not just as a wave, not just as a particle, but as both and neither. It exists in superposition, a quantum limbo where multiple realities coexist, undetermined until measured. Here, a photon doesn't go left or go right. It goes both ways. At the same time, through walls, through you, through causality itself. And what does that mean for you, the light-speed traveler? It means that to truly reach light speed, you'd have to become quantum. You'd have to abandon your classical shell, the solid, familiar you made of atoms and expectation, and embrace the unthinkable, a version of yourself that isn't in one place, but in all possible places, a mind stretched across probabilities. Let's start with the double-slit experiment. Fire photons through 2 slits in a wall, and what you get isn't 2 bright bands on the back screen. You get interference, a wave pattern, as if the photon went through both slits at once. But add a detector, observe the particle's path, and the wave collapses. The interference vanishes. Now the photon chooses a slit. Suddenly, it's a particle again. Observation changes reality. This isn't metaphor. This isn't poetry. This is fact. The universe, at its most fundamental level, does not behave unless someone is watching. Now ask yourself, what happens when you're traveling at the speed of light? From the photon's point of view, no time passes. No distance is crossed. There is no before or after. Could this be why it behaves like it sees all possibilities at once? Could this be why it exists in superposition? Because from light's perspective, everything is one frame, one frozen instant, one eternal now. To become light speed is to become timeless, and to become timeless is to become probabilistic. Your position can no longer be pinned, your experience no longer linear, your thoughts, perhaps no longer thoughts but quantum clouds, hovering across timelines. You wouldn't be you as you know yourself. You would be versions. You would be interference patterns. You would be a superposed self. Now, bring in the uncertainty principle. Heisenberg's ghost hovers here. He tells us you cannot know a particle's exact position and momentum simultaneously. The more you know about where it is, the less you know about where it's going. At light speed, this becomes a cosmic joke, because your momentum is maximal, but your location, utterly undefined. You are nowhere, everywhere, a blur stretched across the cosmos. From your own point of view, you're frozen, but from the universe's frame, you're a quantum hallucination. Let's go further. Quantum entanglement. 2 particles become linked. Measure one, and the other reacts instantly, no matter the distance. No delay, no speed limit. Einstein called it spooky action at a distance. But it happens, and it breaks everything we thought we knew about locality. So now imagine, if you, moving at light speed, became entangled with the rest of the universe, what would that mean? Would your thoughts ripple through the vacuum like echoes? Would your consciousness stretch across stars, touching past and future? Would you even be you, or a cosmic orchestra of connected possibilities? Here's the ultimate terror: decoherence. In the quantum world, superpositions collapse when they interact with the environment, when they decohere. That's what turns probability into reality. That's what makes a cat dead or alive. But at light speed, where time freezes and motion warps, does decoherence even happen? Could you, in that state, escape collapse? Could you linger in a shimmering in-between, neither alive nor dead, neither here nor there, just possible? And now, the final punch, the observer effect. In quantum mechanics, the act of measuring influences the outcome. But who is the observer? If you've become the particle, who watches you? Who collapses your wave function? Who chooses which version of you becomes real? What if no one does? What if you remain in indefinite potential, a ghost within the machine of physics? This is not fiction. This is the current frontier of science. We know relativity. We know quantum mechanics, but we don't know how they fit together. They're like two languages spoken by the same universe, but no one has cracked the translator, and so the edge of light speed remains a fever dream, a paradox, a place where space and time dissolve, and consciousness becomes a question no physicist can answer. Can thought exist in superposition? Can awareness quantum tunnel through death? Can a mind detached from mass and time survive as probability? These are not equations. They are mirrors held up to our species, reflecting both our brilliance and our blindness. We are seekers, and light speed is not just a speed. It's a symbol of escape, of evolution, of awakening, but also of erasure, because to become light is to lose what makes you human. Unless, and this is the crack in the veil, unless there is something in us already quantum, some spark, some ghost, some resonance untouched by clocks or coordinates. If that exists, then maybe, just maybe, we're not trying to become light. Maybe we're trying to remember that we already are. What happens when space begins to ripple? When time stretches like molten glass? When gravity becomes so intense that even light forgets the way out? We have arrived at the outer rim of known physics, where light curves, time drips, and the universe folds in on itself like a dying star, inhaling its own breath. This is not just about speed anymore. This is about structure, the architecture of everything melting. This is the domain of singularities, the places where equations scream and break, where our models of reality, our neat, proud maps, burst into cosmic flames. Let's start with a name we know: black holes, the monsters of the cosmos, born when stars collapse under their own weight. So dense, so heavy, they tear a hole in space-time itself. Nothing escapes. Not light, not time, not even meaning. At their core lies the singularity, a point so infinitely dense, it occupies no volume, mass with no size, gravity with no mercy. A heartbeat made of collapse. But here's the cosmic twist. Black holes aren't just endpoints. They're mirrors, twisted reflections of the very laws we use to understand the universe. Because when you stare into one, you're staring at the breakdown of physics. Relativity says, I can explain the bending of time. Quantum mechanics says, I can explain the jitter of particles. But the singularity says, explain me, and neither theory can. This is where space-time doesn't just bend, it shatters. Light, which once danced in straight lines, now spirals like a leaf caught in a whirlpool. Time, once a steady river, begins to flow sideways, or in circles, or not at all. Your concept of before and after, gone. Inside the event horizon, that invisible boundary surrounding a black hole, the future leads in only one direction, inward. No turning back, no escape routes, only gravity and silence. Here's the kicker: if you were to fall into a black hole, you wouldn't notice the event horizon as you crossed it. No flash, no alarm, no sign, just a slow, eerie drift until your body, and eventually your atoms, are stretched by tidal forces so extreme, physicists have a name for it: spaghettification. You are pulled thin molecule by molecule, As the force of gravity at your feet becomes infinitely stronger than at your head, you are unraveled, not metaphorically, literally. And yet, to a distant observer, you'd never fully fall in. From the outside, time for you would appear to slow and stop. You'd seem frozen, hovering just above the event horizon forever, your image red-shifting, fading, stretched across eternity. Two versions of you, one obliterated inside, one ghosted outside. A paradox, a duality, another crack in reality. But black holes aren't alone. Singularities show up in another terrifying place. The beginning, the Big Bang, the birth of our universe, was itself a singularity. All space, all time, all matter, all energy, compressed into an infinite point, before expansion, before galaxies, before the very notion of before. Time started there. So if singularities are both the birthplaces and the graves of time, what are they really? Are they boundaries or bridges? Einstein's equations allow for something wild. Wormholes, tunnels through space-time, shortcuts across vast gulfs of reality. Mathematically possible, but unstable, flickering, ephemeral. Still, they hint at something profound, that perhaps the universe is not a flat map, but a folded manuscript, written in curls and spirals, where places touch that seem light years apart, where beginnings and ends blur, where cause and effect may kiss. Imagine this: two black holes collide. Gravitational waves ripple across space like stone dropped in cosmic water. We've measured these waves, heard the echo of giants dying, felt the shiver of space-time itself. These aren't just exotic beasts. They are laboratories, portals, warnings, and maybe thresholds. Because here's the question that haunts us. What happens at the center of a singularity? Is it truly a point of infinite density? Or is it the gateway to another realm? Another universe? Another version of you? Some physicists think singularities may be where laws are rewritten, where time could begin again, where the multiverse branches, sprouts, sings. Others whisper darker thoughts, that singularities are where information goes to die, that when something falls in, it's lost forever. But that breaks the sacred law of physics. Information must be conserved. So now, we're stuck again. Two theories, both brilliant, both wrong at the center. This is not a failure. This is the boundary, the event horizon of human knowledge. And standing here, we feel the chill, because we are creatures of pattern, and here, pattern Ds. We are creatures of cause, and here, cause collapses. We are creatures of time, and here, time is undone. So what do? We imagine. We build better models, smash particles together, map the skies, look for echoes of things we cannot see, and still, the singularity remains. Silent, unseen, unyielding. But maybe, just maybe, that's the point. Maybe the singularity isn't something to solve. Maybe it's something to feel, to stand before the abyss, to hear the equations scream, to feel the universe shudder, and to whisper, "We are here. We made it this far." We dared to ask, because the singularity does not answer. It reflects, and in that reflection, we see the deepest truth of all, that the mystery is the message, that the edge is the invitation. What if the speed of light isn't the final barrier? What if the true boundary isn't physical, but existential? What if, at the edge of all science, waits the self? We've traveled far, across warped space-time, collapsing stars, and the impossible terrain of singularities. We've stretched time, shattered space, and questioned causality itself. But now we come to a place science cannot reach, a place math cannot map, a place no particle collider, no telescope, no quantum equation can touch. This place is you, not your body, not your brain, but the thing that looks out from behind your eyes, the still point, the inner observer, the quiet awareness beneath every question we've asked. Call it consciousness, call it self, call it soul, Whatever name you give it, it's here, watching, wondering, aching for meaning. And the truth is, none of what we've explored matters without it. A black hole is only terrifying because you imagine falling in. Time dilation stings only because you fear what you'll miss. Light speed is wondrous because you dream of riding it. Without you, the universe is silent. It spins, it burns, but it doesn't mean. You give it meaning. So here's the real paradox. We spent 11 chapters trying to break the laws of reality, and now we realize the most mysterious force in the universe is the one asking the questions. Let's dive deeper. When you experience the world, color, sound, love, fear, where is that happening? Not in the photons, not in the molecules, not even in the neurons firing. It happens in the awareness of those things, in the field of consciousness where experience unfolds, and science has no equation for that. Neuroscience maps the brain, but not the mind. Physics measures energy, but not meaning. No device has ever captured a thought. No particle detector has ever seen a dream. Some scientists call consciousness an emergent property, a byproduct of complexity, a trick the brain plays on itself. But is that enough? If consciousness is an illusion, who's experiencing the illusion? Quantum physics whispers strange things here. In the double-slit experiment, a particle changes behavior just because it's observed. It collapses from a cloud of probability into a definite outcome. But what is observation? What is awareness? Does the universe behave differently when it knows it's being watched? Is consciousness just a glitch? Or is it woven into the very machinery of reality? Some propose that the observer is not a bug, but a feature, that you are not in the universe is in you. Let's play with a thought. What if, when you move at light speed, your body shreds, time stops, space collapses, but your awareness remains? Not physical, not temporal, not spatial, just a point of being, just presence, like light itself, everywhere at once, timeless, massless, pure. Now ask, is that death, or is it awakening? If the self survives speed, if awareness is not bound by mass or matter, then what are you really? A brain, or a beacon, a vessel, or a window? In Hindu philosophy they say, Tat Tivam Asi, you are that. That meaning the cosmos, the all, the source. In Buddhist thought, the self is not a thing, but a process, a stream, a dream we mistake for a stone. In physics, we search for a theory of everything, but maybe you're already living it. Maybe the theory of everything isn't written in equations. Maybe it's lived. Here's the final, most haunting possibility. You are the universe, waking up to itself, a single flame of awareness, rising from the dark sea of atoms and stars. Everything you've seen, black holes, quarks, galaxy, photon, is you in another form. And this moment, you, listening, thinking, feeling, is the miracle. So what now? Where do we go? Once we've touched the speed of light and looked beyond it, there are no maps here, no road signs, only a whisper. Be aware of the mystery, be aware of the awe, be aware of the miracle of being a question that can question itself, because that is the greatest power in the cosmos. Not gravity, not light, wonder. We end where we began, with a simple, impossible question. What happens if you travel at the speed of light? The answer is more than physics. The answer is, you become light, and perhaps you were light all along. Fade out, echoes of stars, one last breath of silence. Then, you are not in the universe. The universe is in you.